Good morning, good afternoon. Thank you for joining me. I'm going to be covering section 7.8, formulas for binary ionic compounds. I'm going to be using Pear Deck and I'm going to be working with fifth period. And remember, the Pear Deck is what you see here on your packet. Okay, so don't be confused. All right, so let's get started, guys. How does shorthand work? How does shorthand work? Hold on, let me check my cameras, make sure nobody's trying to break in. Oh, it's my husband. Okay. So how does shorthand work? Shorthand, who's going to help me read?
Shorthand was a very popular way of recording speech, especially in dictating letters and in court testimony. Instead of trying to write out all the words, the person taking the dictation would use a set of symbols that represent syllables or words. The pages above show a shorthand version of A Christmas Carol, written by Charles Dickens. Unless you know shorthand, the passage is meaningless, but knowing shorthand allows you to read the classic story. Different professions also use a type of shorthand in communication to save time. Chemists use chemical symbols in communication to indicate specific compounds. There are two advantages to this approach. One, the compound under discussion is clearly described so there can be no confusion about its identity. Two, chemical symbols represent a universal language that all chemists can understand no matter what their native language is.
Thank you, Alexia. So if you know how to read formulas, it doesn't matter where you are in the world, these formulas should not change. Okay? Maybe how the letters are written might change, but for the most part, you should be able to recognize formulas no matter where it is you're studying. Okay. Like we said, shorthand is just a very short and easy way of remembering what was said, but in a very small format. Okay, so you're talking about 3 different words that are covered in just one word. So writing formulas for binary ionic compounds, that's the topic for today. If you know the name of a binary ionic compound, you can write its chemical formula. Start by writing the metal ion with its charge. So you're going to write the symbol along with the charge. And you're going to do it for both the metal and the non-metal. Because the overall compound must be electrically neutral, decide how many of each ion is needed in order for the positive and negative charge to cancel each other out. Okay, so anytime you have a compound, the metal charge and the non-metal charge must equal 0. So if I have a +1 and a -3, how many do I need of the +1 so I can cancel out that -3? Right. If you have 3 times +1, that's going to give you a +3, which will cancel out that -3 and you have 0. This is what we mean. Okay. In the case of aluminum and nitrogen, which is what you see here, well, this 3 that you see must cancel with this 3. How many do I need of aluminum? Well, just 1. How many do I need of nitrogen? 1, right? 1 times 3, 3. 1 times 3, 3. Except this one's positive, this one's negative. You add them together and you get 0. 0. Settle. Since the ions have charges that are equal in magnitude, one of each will be the lowest ratio of ions in the formula, and the formula for aluminum nitride is AlN. Okay? AlN. And remember, nitride is not going to be on this list. You can look all you want, but you will never find nitride on here. Remember, nitride does not exist. We changed the ending to IDE. What was the original ending? Nitrogen. For today, you're only going to use the top of this column and all of the column on the left. We are not using the bottom half over here where it says polyatomic oxyanions. That comes later. Okay. Now you have your first question. What is the formula of the compound formed between strontium ion and nitrogen ions? All right, so I'm going to go to Jamboard. We have strontium Sr and nitrogen N. So if I have strontium Sr, if I have nitrogen capital N, I need to look at the list to see what is the charge for the metal and the non-metal. All right, so here under reference materials, you have this valence sheet that you need that has the list of the charges for each element that we're going to be using. If you look up strontium Sr right here, the charge for that element is a positive 2. So that's what I'm going to write in Jamboard. Except I'm going to write the 2, then the charge. It's the same thing. In chemistry, they just flip it. For nitrogen, or nitride, as you might see it, nitrogen, you got to keep going, right? Nitrogen, I don't see it. Right here, nitrogen. What's the charge? It's a -3. So on Jamboard, I'm going to put 3 with a negative behind it. So how many do I need of each in order for them to cancel out?
1.
You need just 1?
2.
2? Well, if I have here, if I have 2 strontium and a +2, I get a +4. That's not going to cancel. Let's go a little bit more, okay? Let's go a little bit higher. Usually, America, what you want to do is you want to look at the number on the opposite element and use that. Okay? So if I have nitrogen over here with a 3, I'm going to take my 3 from nitrogen and I'm going to multiply it by the +2 for strontium. That'll give me a +6. Now for nitrogen, I know I have a -3. Well, what's the number for strontium? 2. That'll give me, oops, not positive, -6. Does that equal 0? Yes. So for my formula, I need 3 strontiums and 2 nitrogens. Okay? If you look at the presentation, that's letter B. Letter B. Letter B. You have other examples. Ions for lithium oxide. Lithium oxide. Lithium, Li, oxide. Isn't that oxygen, right? We took off the last part. We put back the original oxygen. Okay, so now let's use the sheet. Lithium is at the very top. It's got a +1 charge. Oxygen. For these guys, you know how they have all these other numbers? Just look at the first one. Just look at the first one. For oxygen, -2. So I got a +1 and -2. How many do I need of lithium? Look at the number for oxygen. What's the number for oxygen? What's the number for oxygen, guys?
-2.
Just the 2, not negative, okay? I'm more than likely going to need 2. For oxygen, well, what's the number that I have here for lithium?
1.
Very good. So if I multiply this guy and this guy, I get a +2, right? If I multiply negative 2 by 1, I get a negative 2. Does that equal 0? It sure does. So what's going to be my formula? Li2O. Never show ones. Never show ones. Okay? Some more practice. Okay, now instead of, trying to figure out how many do I need in order to cancel out, there's another easier way. An alternative way to writing a correct formula for an ionic compound is to use the crisscross method. Ion charges are crossed over to become the subscript of the other. Signs of the charges are dropped, shown below in the crisscross method for aluminum oxide. Okay, let's clear this out. If I have aluminum with a +3, oxide or oxygen with a -2, I need to use that cross down method. And remember, when you cross them down, the plus and the minus, they disappear. Do not cross that down. Pluses and minus don't cross down. The only thing that crosses down is the number. 2 will go here, 3 will go here. So when you write your formula, you're going to write the 2 that cross down for aluminum and the 3 that cross down for oxygen. And if you want to double check if the charges cancel out, well, what's this guy times this guy? +3 times 2 gives me a +6. -2 times 3, -6. Very good, Oscar. Yes, sir. This should be my final answer for aluminum oxide. Always just cross them down. Just the numbers, not the symbol. Just the numbers, not the symbols. The red arrow indicates that the 3 from the +3 charge will cross over to become the subscript of O, or oxygen. The 2 from the -2 charge will cross over and become the subscript for aluminum. The formula for aluminum oxide, Al2O3. What do you think about that, guys? Maybe a little bit yes, a little bit no? On a scale from 1 to 5, 5 being I got it, miss, 1 being I'm lost, miss, where would you land? Oscar says he would land as a 4. He's almost got it. What about Alexia or America? Where are you at? Excellent. Okay, great. You think you got it, right? You think you got it. Okay, let's see. Try this one. Use the cross-down method to write the correct formula for the elements listed below. Type it. And I know you can't make the number small, but just type it. How would it look? And you can type it on Pear Deck. You can type it on Google Meet, wherever you want to post it. Should I see a plus and a minus, Oscar? Use the symbols. Put the symbols in there. I don't know for which one you're telling me the 2 and the 3 belong to. It should be CR, a number, O, and then another number. Remember, do not use that plus and minus. They go away. Once you cross them down, they go away. All right. So if I have CR with a 3 plus, O with a -2, and they cross down, this guy goes here, this guy goes here, The symbols go away, right? Cross them out. What's my formula, Oscar? Very good. Cr2O3. Okay? And just write them next to each other next time, okay? Cr2O3. Great job, sir. Great job. Okay, let's go back to the presentation. All right, there's something that you have to be aware of. Watch out for it. Be aware that ionic compounds are empirical formulas and must be written as the lowest ratio of ions. If you can divide those subscripts, divide them. If you can't, leave them the way they are. In the case of aluminum nitride, okay, the crisscross method would yield a formula of Al3N3. Okay, let's look at that. Originally, aluminum was a +3, and then nitrogen was a -3. If we cross this down, we'll end up with this, right? Agree or disagree? Agree or disagree? What do you think? Is this what I end up with?
Yes.
Okay. Can we divide them though? Can we make those threes smaller? What number can I divide both of those 3 by to make them smaller? If I divide them by 1, I get the same thing, Oscar. Try again. What can I divide both of these numbers by? Can I divide them by 2? Definitely not. What comes next? I can't divide them?
No.
Watch me. Nah, just kidding. Watch. Why don't I divide them by the same number? 3 divided by 3. And 3 divided by 3. We don't show ones. What's my formula? ALN. We don't show ones. Be careful. It doesn't happen a lot, but just watch out for it. It might come up. Okay? Try this one. This one. It must be reduced. Following the crisscross method, write the formula for lead 4 oxide. All right, so we're talking about lead 4. So we're going to start here. Pb with a +4, O with a -2. If we cross them down, we end up with Pb2O4. Okay, Pb2O4. Can we divide them? What can I divide both of these numbers by? What can I divide them by? Very good, Oscar. What would my formula be? Two divided by 2, 1. We don't show ones. 4 divided by 2, 2. This is my final formula. Now, I want to point something out to you before we move on this slide. You see how this guy has a Roman number? This metal has a Roman number because this metal, lead, has more than one charge. Check it out on the list. If you look up lead, right here at the bottom, it can either be a +2 or a +4. We use the 4 because of the Roman number. This Roman number tells me if I'm working with lead 2 or with lead 4. There's 2 different versions of it, right? It's like when you have siblings. Excuse me. You have a brother and a sister, right? Think of the brother as being the 2, the sister being the 4. You have to tell me which sibling I'm working with. Is it sibling 2 or is it sibling 4? In this case, it was sibling 4. Okay? Try this one. What if you have chromium 6 nitride? Chromium 6 nitride. If you look up chromium, chromium has different versions of itself. Look at that. There are 3 siblings. The first sibling is a +2, the second sibling is a +3, and the third sibling is a +6. They're telling you that you're working with number 6. What's my formula? Try it out. Okay, you did the cross down method correctly. But Oscar, can you reduce those numbers? Can you make them smaller? Can you divide 3 and 6 by a number to make the number small? Somebody raise their hand. All right. Yes. Yes, sir. Okay. So right now, Oscar is looking at, so he had CR plus 6, what was it? N, -3. He crossed them down, and he ended up with CR3 and 6. Perfect. Right? But both of those can be divided, can't they? We can divide this guy and this guy by 3. CR. 3 divided by 3 is a 1. So I'm going to write here just CR, right? Because we don't show ones. N. 6 divided by 3, 2. Caitlin, you have it right, except you have your elements backwards. It's correct, but you switched your elements. Don't switch the elements. CR must go first. Okay? Questions? Oh my God, you guys are so smart. I love it. You guys are awesome. I don't like that video. We're going to use the second video. It's got like 4 examples. I hate commercials. I hate them. Hurry up. Hurry up. Hurry up. My husband's home, so he might be using some of the bandwidth. It might be a little slower than usual. I don't want to tell him anything.
So we started off with sodium chloride. And the first thing that we did, and it's the most important step, so get that in, I guess, when you're studying.
I really like the steps that he comes up with to help you guys remember what to do. My suggestion, I would write them down because they're easy to remember. They're summarized already. My suggestion, make a note of it.
Remember, whenever you're given a name, a compound, always refer to your periodic table and identify metal and non-metal. And that's the first step. Okay, so we know metal is the sodium, chloride is the non-metal. So now we go into the 5-step, what I like to call the 5-step crossover rule. The first step says, write the symbol. So what's the symbol for sodium? Na. What's the symbol for chloride? Cl. Next step says, write the charges. So if we refer to our periodic table, we'll notice that sodium has a +1 charge and chloride has a -1 charge. Step 3 of the crossover rule is pretty much where the name comes from. Cross over the charges now from the top to the bottom. So watch now how the charges move. The positive one moved down and crossed over. Okay. Step number 4. We're going to remove the charges, so we no longer need the negative and the positive, so we remove that. And step number 5, we're going to simplify the number, so you treat it like a ratio and you try to reduce it to lowest terms. 1 to 1 is already reduced to lowest terms. So we do the second part of the last part of the 5-step crossover rule, and that is to simplify the numbers and to remove the ones. So we no longer need the ones. So what is the formula for sodium chloride? Well, we put it all together and it becomes NaCl. Now let's look at the configuration of how this calcium oxide.
I forwarded because he covers something that we haven't gotten to yet. Okay, we're just looking right now at the formula writing process that he discussed. I really like the way he discusses it.
Same thing. First step, identify metal and non-metal. So calcium is the metal, oxide is the non-metal. Next step, we're going to write the symbols, Ca and O. Step number 2, write the charges. So you refer to your periodic table. Ca is a positive 2 charge. O has a negative 2 charge. Step number 3, where the name kind of comes from, the 5-step crossover rule. They cross over the charges from top to bottom. Now let's watch how the charges move. Okay, they move from the top of one atom to the bottom of the other. Step number 4, we're going to remove the charges. We no longer need them when writing out our chemical formula. Step number 5 says we're going to simplify the numbers. That's the first part of the last step. And we have a ratio of 2 to 2. So 2 to 2 ratio simplifies to 1 to 1. So we write it into 1 to 1. Or we don't really need to, because look at the final step. It says remove the ones. So we remove the ones, and the formula for calcium oxide is CaO. Okay, let's look at our next example. Magnesium chloride. Again, first step before you do anything, identify metal, non-metal. Magnesium is the metal. Chloride is the non-metal. So now we can go on and use the 5-step crossover rule. Now, if you do not find a metal and non-metal, if the two happen to be non-metals, you cannot use the 5-step crossover rule. Okay, the 5-step crossover rule is only for metal and non-metal. So now we can start with the 5-step crossover rule. So we're going to write the symbols, Mg and Cl. Step 2, we're going to write the charges. So the charge for magnesium, +2. The charge for chloride, -1. Step 3, we're going to cross over the charges from top to bottom. So from top to bottom, top to bottom. Step 4, we're going to remove the charges. Step 5, the first part says to simplify the numbers. We cannot simplify it because it's already in lowest terms, 1 to 2. So now the last part of the final step is to remove the 1. So we're going to remove that 1. And now the formula for magnesium chloride is MgCl2. Now let's look at how that bond is arranged. So we draw, same thing. We're going to identify metal, non-metal.
Last example.
Calcium is the metal, phosphide, non-metal. Write the symbols, Ca and P. Step 2, we're going to write the charges, +2, -3.
All right, remember, when it comes to this formula, they're not the same number. We can't cancel them out. We have to cross them down. 3 will come to the Ca, 2 will come to phosphorus, and you should end up with Ca3P2.
Step 3, we're going to cross over the charges from top to bottom. Watch how they move. Okay, step number 4, we're going to remove the charges. So say bye-bye to the charges. And finally, the last step says simplify the numbers, remove the ones. 3 to 2 is already in lowest terms. We cannot reduce it. Are there any ones? There are no ones, so we cannot remove any ones. So the formula is, as is, Ca3P2.
Awesome. And there's some practice questions, but we have our own practice. So let's close that out. All right, in summary, formulas for binary compounds begin with the metal followed by the non-metal. The second point, positive and negative charges must cancel each other out. Third point, ionic compound formulas are written using the lowest ratio of ions. Your review questions. Number 1, write the formulas for the binary ionic compounds formed between the following pairs of elements. 2, write the formula and give the name for the compound formed by the following ions. 3, give the names for the following compounds. It's been really difficult to get to number 3. Usually for first and second, first, second, and fourth, I was only able to do number 1 and number 2. If we don't get to number 3, it's okay. We have 8 questions that will help us review. All righty. Let me stop that. Hold on. End session. How do I stop the recording? Oh no. How do I stop the recording? Oh, there we go.